Let's suppose I have two orthonormal basis vectors set up as columns of a matrix Q. What is Q transpose times Q? And what does this result imply about Q transpose? Okay, so let's start by taking a matrix Q. And Q consists of two column vectors that are orthonormal. So Q has a column vector Q1 and another column vector Q2. Okay, now Q1 and Q2 are column vectors. And they're orthonormal basis vectors, which means two things. Well, it means a couple of things. It means Q1 dot Q2 is equal to 1. It also means that Q1 dot Q1 is 0. I'm sorry, opposite way around. Q1 dot Q2 is 0. Q1 dot Q1 is 1. Q2 dot Q2 is equal to 1 as well. Okay. Well, if we try to multiply out Q transpose times Q, let's write out Q transpose. So that's it's a vector, a column vector, consisting of Q1 transpose and Q2 transpose. Obviously, the transpose here turns these columns that are Q1 and these columns that are Q2 into rows that are Q1. So this row here is going to be Q1 transpose, so this thing sideways, and it's going to be Q2 transpose, so this guy sideways. So Q transpose times Q is going to be Q transpose, consisting of row Q1 transpose and row Q2 transpose, times Q, which is column Q1 and column Q2. Now, my first vector here, my Q transpose, that's 2 by 1. And my Q is 1 by 2, which means I can do this multiplication, and my result is going to be 2 by 2. That result is going to be what I get when I multiply this row by this column. So it'll be Q1 transpose times Q1, right? This row dotted with that column. This row here, Q1 times column Q2. Q2 transpose times Q1. And then Q2 transpose Q2. Now we know Q1 transpose times Q1 is the same thing as the dot product of Q1 and Q2, Q1 and Q1. So this dot product gives us a 1. Q1 transpose times Q2 is the same thing as Q1 dotted with Q2, which we know is 0. Q2 transpose times Q1 is the same thing as Q1 dotted with Q2, which we know is 0. Q2 transpose times Q2 is Q2 dotted with Q2, which we know is 1. And so what we end up with is the 2 by 2 identity matrix. And so Q transpose has to be the inverse of Q because their product gives us the identity matrix. And that's true in general. If we have two orthonormal basis vectors set up as columns in a matrix, the product of the transpose of the matrix with the original matrix gives us the identity matrix.